Hi, welcome to my video on graphs of cos and sine theta, part 2. And this is in terms of graphing with a radiant. We did a unit on a radiant, a whole unit on a radiant. If you want to look back at that unit and go over what a radiant is and changing that. But I'll do a review here on this page. A radiant is in terms of pi, or it could be a decimal, like pi is 3.14 times 2 is 6.28. You can change all these to decimals. But in terms of pi, 2 pi radians is equivalent to 360 degrees. Pi is equivalent to 180. So the way I do it most of the time, I keep pi in my head as 180 degrees. So 180 divided by 2 is 90. 180 divided by 3 is 60. 180 divided by 4 is 45. 180 divided by 6 is 30. And also, in that unit on radians, to change a radiant to degree, you multiply by 180 over pi. So to do an example, I want to change pi over 2, which is a radiant, to a degree, so I multiply by 180 degrees over pi. Notice I have a pi here, so I divide by pi and they'll cancel. So 2 into 180 goes 90 degrees. That's how you change a radiant in terms of pi, multiplied by 180 over pi. If I want to change a degree to a radiant, then I reverse it, reciprocal. I multiply by pi over 180 degrees. So let's take 60 degrees, and we multiply it by pi over 180. So notice here, pi is in the numerator, so I put pi in the denominator to cancel out, so 180 goes on the top. Here I don't have a pi, it's 60, so I multiply by pi over 180. 60 goes into that once, 60 goes into that 3, so that becomes pi over 3. Again, that was practice when we did the unit on radians, but I'm just reviewing now. Also, another idea I want to review is multiples of radians. So this is pi, then I want to look at 2 pi. So that's 180, 2 pi is 360. If I have pi over 2, that's 1. So let's make it 2 pi over 2, and also make it 3 pi over 2, and make it 4 pi over 2. Notice I went from a 90, and then I double it, so that's 180. By cancel, so that's a 90. This is 180, so that leads me back to here. 3 pi over 2 is, pi over 2 is 90 times 3, so that's a 270. 4 pi over 2, the 2's cancel, and I get a 2 pi. So that brings, so the 90s are in terms of pi over 2 when it's reduced. So this is pi over 2, 90. This is pi over 2, which is 90 times 3, so that's a 270. What about pi over 3? That's 1. So let's do 2 pi over 3, and let's do 3 pi over 3, 4 pi over 3, and keep going, 5 pi over 3, and then we go to 6 pi over 3. That's the multiples of pi over 3. Remember, pi over 3 is 60, so that's 60. Pi over 3 is 60 times 2. That's pi over 3 is 60 times 3 is 90. Pi over 3 is a 60 times 4 is 240. Pi over 3 is 60, so 5 times 60, so that's a 300. And that's a pi over 3 times 6, so that's a 2 pi. So that's, they cancel, so that's 2 pi. Notice they don't cancel here, they don't cancel here, the 3's cancel, so that's the same as that pi. So the pi over 3's are 1, 2, 4, and 5. Notice the 1, 2, 4, and 5, they don't cancel. So that's 160, that's 260, that's 260 degrees, not 260, that's 60 times 2. This is 4 pi over 3, this is 4 times 60, because that's pi over 3 is 60. This is 5 times 60. So you can see that pi over 3 is 60. That's a 300. That's a 60. So that's 240. That's a 60. That's 120. Let's continue with pi over 4. Little skill that I practice. So that's 1 pi over 4. This is 2 pi over 4. 3 pi over 4. 4. 5. 6. 7. 8. But because they're even, the 2 cancels into the 4 twice, so that becomes a 90, which is right there. 3 pi over 4 can't reduce because it's an odd and even number. 4 pi over 4 becomes a pi. 5 pi over 4 can't reduce. 6 pi over 4, 2 into 4 goes 2, 2 into 6 goes 3, so that's 3 pi over 2. That's right there. 7 pi over 4 is odd and even, can't reduce. 8 pi over 4 is 2 pi. So notice the pi over 4s that's left, the denominators are 4s. So these are multiples of 45. 45, that's 3 times 45. That's 5 times 45. That's 7 times 45. So when they don't reduce, again, that's a 60. This is a 60, but there's 2 of them. This didn't reduce, so that's a 60, 4 of them. And that didn't reduce, so that's a 60, 5 of them. And pi over 6, let's go. 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and I keep going. And how far am I going to go? I'm going to go as far till I get to double the denominator. 10, 11, 12. So what is 12 pi over 6? That's a 2 pi. Every one of them ended in 2 pi. So if I go back and reduce here, that's pi over 3. This is pi over 2. Reduce. 2 pi over 3. 5 pi over 6 can't reduce. 7 pi over 6 can't reduce. 8 pi over 6 is 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 is 5 pi over 3. So I reduced all the ones that were even and multiples of 2, 4, and 2, and 3. So the ones that didn't reduce is pi over 6 is a 30. 5 pi over 6, that's 30 times 5, that's 150. 7 pi over 6, pi over 6 is 30, so that's 110. Oh, sorry, 210. And I got 11 pi over 6, so that's 30 times 11 is 330. So when you don't reduce, then you got the multiples of that denominator. So notice the pi over 3, that's a 60. That's the reference angle. Pi over 4 is 45. Divide by 4. That's a reference angle. Pi over 6 is 30. That's a reference angle. So this pi over 3, pi over 4, pi over 6, they're the reference angles that's in your corner of your right triangle when you draw your circle. So I'm going to put all these here on this circle now. So there's a 0. So just this point here is 1 comma 0. I'll put that in first just put on the outskirts here. 1. Put it on the outskirts. Negative 1, 0. So this is 0, negative 1. Because the radius of this circle is 1. So now, this is a 0. This is, if I go along, this is 30, so that's a pi over 6. This is a 45, that's a pi over 4. This is pi over, that's a 30, 40. So this is a pi over 3, that's a 60. So if you go over here, so this is 60. So this is, each of these are 30, 45, 60, 90, 30 more. So that if that's a 30, so that leaves me with 2. If I think about it, if that's opposite of this one, so that's a 60 there. So this is a 60. So this is 2 pi over 3. And this one is 3 pi over 4. And that's a 30. So this is a 30 reference angle. So this one is 5 pi over 6. So think of it. This is 120, 135, 150. So you can see that whatever you have here across from it will be a reference angle. So that's a 30. This is the 30 reference angle. So if I drew a right triangle here, I would get a reference angle here of 30, which is pi over 6. And this reference angle here, if I drew the right triangle down here and here, this reference angle would be a 45 because it's a pi over 4. This is a pi over 3. So if I drew a right triangle here, coming down to here, this reference angle over here is pi over 3, which is 60, which is 120. So if you think about it, this is a 120 degree rotation. If you draw a right triangle, this is a 60 degree angle here. 180 minus 120 gives you a 60 degree reference angle. But I know it's 60 because I got a pi over 3, and there's two of them. So that's a 120 degree rotation. And draw the right triangle, and you get 180 minus 120, you get a 60 degree. But the denominator is the reference angle. Pi over 3, 60. Pi over 4, 45. Pi over 6, 30. So if I come right here, this one is pi. That's 0. That's pi. So this one is related to this one. So that's a pi over 6. But it can't be 4 of them. But it can 5 of them is here. So it must be the next odd number, 7. This is a pi over 4 related to this one. So that's 3, 4, 5. So we go with 5 pi over 4. Odd. It has to be an odd number. And this is pi over 3, and it won't reduce. So that's a pi over 3. What do we have? We have 3. We can't put a 3 here. So we got a 2. There's the 3 over 3. So this is a 4. So notice, if you think about it, what's this angle? This angle here is 30 times, that's 220. Sorry, 210. This angle here is 225. So it's 545s. This is 210. So that's 730s. And this one here is 240 degrees. And that's 60 degree reference, but there's 4 of them. That's how I learned what to do. And this is a pi over 3 here, because right straight across is the same. And we need, that's a 4, so this is a 5. Why? Because that's a 300, and that's 560s. This is a pi over 4, and we need an odd number, so that's 7. Notice I'm getting close to the 8 pi over 4, which is 2 pi. So that's 745s, so that's 315. And this one is a pi over 6. That's a pi over 6. This is a pi over 6 raised straight across. That's a pi over 6 raised straight down. And how many of them? Well, we have 330, and that's 30 degrees divided into this makes it 11 pi over 6. That's 30. 180 divided by 6 is 30. 11 30s is 330. So that's in terms of a radian. So that's the same as degrees. So when I look at radians, I think of degrees. I always look at the degree instead of the radian. Then I won't make a mistake. Well, I have a grid drawn here, and I want a graph in terms of a radian. But what I do, I look at the radian as a degree, and I know what a degree is doing because I practiced it. So let's have a look at it. Let's look at, I'm going to do some info here. Now, cos and sine, that's the x and the y. And in terms of a right triangle, we have SOHCAHTOA, SOHCAHTOA. Sine is opposite over hypotenuse. That's right from the basic trig. Cos is adjacent over hypotenuse, and tan is opposite over adjacent according to SOHCAHTOA, which is a unit that I did on right triangles. So cos is the x, sine is the y on the unit circle. Now, the second idea we looked at in the trig that we went through was we did a grid, and we looked at what we call, some people call it the CAST rule, C-A-S-T is the CAST rule. This is for the positive trig ratios. That's the positive trig ratios. C, but the only thing about the CAST rule starts in quadrant 4. C-A-S-T. C stands for cos, A is all, S is sine, and T is tan. But the one I like is add sugar to coffee. Why do I like that? Because add is A starting in quadrant 1. It's still all sine, tan, cos, but I like add sugar to coffee, quadrant 1, quadrant 2, quadrant 3, quadrant 4. Whereas the CAST rule starts in quadrant 4, because A stands for all, and everything is positive in quadrant 1. Everything. Sine, cos, and tan is all positive in quadrant 1. Why? Because the x is positive in quadrant 1, and the y is positive in quadrant 1. Tan is the y over the x, so everything is positive. Also, when I look at this, I keep in my mind the right triangles, the 30 and the 60 right triangle, which, if the hypotenuse is 1, that's a half, and that's root 3 over 2. Also, the other one I keep in mind is the 45 right triangle that we practiced in earlier trig units. 45, 45 right triangle. Hypotenuse is 1. This side is root 2 over 2, and this side is root 2 over 2. So in terms of a radiant, it's the same numbers, but 30 is pi over 6. 180 divided by 6 is 30. 60 is pi divided by 3. 180 divided by 3. So that's a 60. So that's root 3 over 2, and that's a half, and that's 1. So if you look at it in terms of a radiant, well, what I do, I change my radiant to a degree, and I work everything out in terms of a degree, because the degree don't fool me. And 45 is pi over 4 reference angle. 45 is a pi over 4. The two angles are equal, so the sides are root 2 over 2, root 2 over 2. Again, if you have radians, look at in terms of degree, and you hopefully don't mix it up. And besides that, I've learned with my calculator that root 3 divided by 2 is a decimal, and I look at 0.87. Root 2 over 2, if I use a calculator, is 0.707. 0.7 roughly. And we know what a half is. So if I use a calculator and I do cos or sine, and I get 0.7, I know it's root 2 over 2. But if you use, excuse me, if you use your triangle, you'll see it. If you get 0.87 for sine or cos, then that's a root 3 over 2 as an exact value. But in graphing, you have to use the decimals. You can't use the roots. You can use a half as 0.5, but you can't put root 3 over 2 on your graph. You could put 0.87. You could put 0.7. 0.87 is here. 0.7 is here. Half is here. 0 is here. 1 is here. And then the negatives. So when you're graphing in terms of a radiant, I change my radiant to degree. Or I, again, use my calculator. But if I use these, then I won't go wrong. So in terms of the circle, get back to the circle again. This point right here is 1, 0. This point right here is 0, 1. This point right here is -1, 0. And this point right here is 0, -1. So this is 0. This is, in terms of a radian, this is 90, which is pi over 2. This is pi, which is 180. And this is 270, which is 390s. And this is also 0 or 2 pi. Or we can add the negatives, like negative. This is 3 pi over 2 is also a negative pi over 2, negative 90. This is pi going this way, 180, or it's a negative pi going this way, or negative 180. So these points right here, this is a 30. So a 30 is pi over 6. This is a 45. 45 is pi over 4. And this is a 60, which is a pi over 3. So this triangle right here is the same as this one, because the reference angle is pi over 6. And this angle right here is pi over 3. So this triangle right here is identical to this one. So what's across from here? That's a half. And what's this length of this side right here? That's a root 3 over 2. So that means this point here, x is root 3 over 2 and a half. So that means that as a decimal, that's decimal 87. And a half is 0.5 or 0.5. So there's in return to a radian. So in graphing these, memorizing this, you can graph in terms of radian. So let's graph this one. Pi over 6 is a 30. And this is if we do x equals cos theta, then this is theta, and this is x, or you can call it cos theta. So if you take 0 degrees, cos is the x, you get a 1. Pi over 6 is 30, and the cos of 30, here's 30 here. If you look at the radian, I look at a degree. So the cos of 30 is root 3 over 2, and root 3 over 2 is 0.87. So there's 30.87. I'm just going to put it approximately there. This is a 45. Pi over 4 is a 45. So what's the cos of 45? Root 2 over 2. And root 2 over 2 on the calculator, if we convert it, is 0.7. So there's 0.7. Let's take it just a rough estimate right there. And this is pi over 3, which is a 60. So 60, what's the cos of 60? Cos is the adjacent, which is a half. Right there. And we have a 90, and the cos of 90 is 0. Right there. There's 90, pi over 2 is 90, and the cos of 90, cos is the x. So notice it's the same as what we did before. So what we have up here, we have down here. So there's the half. Then we have the 0.7. Then we have the 0.87. And then we have negative 1. So you can see the pattern flowing through. And then when we move, I got to make sure now that this is, I got a half. That's, I'm sorry for that. I got to use a whitener now. I just put them in the wrong locations. I'm just going to cover them up. This whitener, for me, always works pretty good. But sometimes when you're graphing this, trying to explain it, you got to be careful. So this is a 0. This is a 0.5. This one right here is 0.7. This one here is 0.87. And now we got the negative 1. So now we go back up. We got a 0.87, 0.7, a half, and we have 0. Notice this is a 90. This is 270. 270 is 0, cos. And this is 60. That's 60 times 4 is 240. And that gives you, to get a calculator on 240, you get negative a half. And we continue going up. So here we are. We go, there's 0. And this is a 60, so it's a 300. So you're up to half. Then you're up to 0.7. This is 330. 330 is 0.87, and 2 pi is 360, which gives you the cos of 360 is 1. And so I'm just trying to draw what the graph is doing. You can see. Here we go. I just got more points. I just got more points on the graph. That's all. There it is. So you can work it all out. You can use a calculator, work it out according to this, knowing that these numbers are in decimals. These are the exact values right here. So these are decimals. And if you do sine, if we do y equals sine theta, then this is theta, and this is, you could say that's the y or the sine of theta. And again, you can use this grid, but we know what this is doing. Let's see, or use a calculator. The sine of 0 degrees, the sine of 0 is the y, so we got a 0. Now, if I go to the sine of 90, the sine of 90 is 1, because it's the y. So it's right up here. So that means the graph is leaving here and going to here. But this is a 30. And the sine of 30 is a half, which is 0.5. And the sine of, this is a 45, the sine of 45 is root 2 over 2, which is 0.7. It stays there. And this is a 60, so the sine of 60 is root 3 over 2, which is 0.87. So there it is there. So we're getting the graph doing this for sine. So it's just more points on the graph, that's all it is. But I convert them. Notice this is a 60 reference, 120. This is a 45 reference. So that's a 135. And since it's a 45, I'm looking at these triangles. This is a 30 reference. So I'm looking at this triangle. This is, again, that's a 30. So I'm looking at these triangles. This one here. And this is a 45. So I'm looking at this triangle. This is a 60. So I'm looking at this triangle. In terms of sine, if I look at the triangle, cos is the adjacent, sine is the opposite. But if I'm looking at the circle, cos is the x, sine is the y. And we just continue this now, and I keep it high, and I go to 0.7, I go to the middle, I go to 0, and I go to negative 0.5, I go to 0.7, I go to 0.87, and then I go to negative 1. Going back up, I go to 0.87, I go to, keep that higher, 0.7, then I go to the half, and go to 0. So it's the same pattern, and but you see it and get used to it. But notice the sine graph is an S, sideways S. Sine, S-I-N, begins with S. So the sine graph is a sideways S. It goes middle, top, middle, bottom, middle. That's a 1, that's a negative 1, and these are zeros. And the cos graph, C-O-S, that's a C. So the cos graph is a sideways C going like this. So that's in terms of a radian. But I change my radian to a degree. And I don't get mixed up that way. Hopefully don't get mixed up. Now I have a circle drawn. The radius of the circle is 1. Again, it's 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So this is the x. The x here is 1. X over here is negative 1. And the y's are 0. Right here, the x is 0 and the y is 1. Down here, the x is 0, y is negative 1. And in terms of radians, this is a 0. This is pi over 2. This is pi. And this is 3 pi over 2. Remember, that's a 90. That's 180. That's a 90 times 3 is 270, and that's a 0, or is it 2 pi? And we want the graph, this is theta, and we want the graph, put cos theta here, or we can put an x. That means I'm looking at x equals cos theta. So, if I look at the 0, cos is the x, that's x is 1. I'm looking at the 90, which is pi over 2. That's the 0. Pi over 2 is cos is 0. Then I look at, in the middle, that's the 180. And that's the 3 pi over 2. So that's 90, 180, 270. So look at theta. Cos theta at the pi. So there's pi, 180, and cos is -1. So there it is, right there. And 270, the cos is 0, right there. And 2 pi is 360, the cos is 1. So we have a sideways S. So let's see. There it is. That's the cos graph. And if we continue back here, once I see the pattern, I'm going to here, I'm going to the bottom, I'm going to the middle, I'm going to the top. So there's also the other side, which is the negative. And you can check that out to see if you're right. So -2 pi, here's 0, -2 pi is all the way around right back to here. So that's a 1. That's negative pi over 2. That's negative pi, and that's a -3 pi over 2. Again, that's a 90, 180, -90, -180, -270, -360. So a -2 pi over 3 is right there. So the cos is the x, 0. Perfect. So that's the graph in terms of a radian. And we got radian 2 pi, so that's a pi, and that's pi over 2. And that's 3 pi over 2. 90, 180, 270. That's a 90 times 3, 270. This is a negative pi over 2, negative pi, -3 pi over 2. So that's 360 negative, that's 270 negative. Pi over 2 is 90 times -3, -270. And we're graphing this, we're going to graph sine theta this time, which is the y. So y equals sine theta, and this is theta. So look at graph. The sine is the y, 0 degrees. 0 degrees, the y is 0. 90, the sine is 1. 180, the sine is 0. So that's 180. So I got 0, 1, 0. Now I go to -1 and I go back to 0. There's the graph. You can check it out what these are doing. And this one is 1, 0, -1, 0, 1, 0. So 0, -1, 0, and check it out. -90. -90 is right here. And we're checking the y, which is -1. So this graph checks. And that's a review of graphing with radians. But again, I change my radian to degree, and then I don't get mixed up. And if I use my calculator, if I wish, then I can keep it in degree mode and punch into degrees. Cos of 120. Sine, and notice at 0.87 is root 3 over 2. 0.7 is root 2 over 2. But be careful. If you're using your calculator, yes, great. But if you're on a quiz or you're somewhere where you can't use a calculator, it's best to follow the triangles and where sine is positive. Remember, cos is positive where x is positive. Cos is negative where x is negative. And sine is positive where y is positive. Sine is negative where y is negative. So that's a review. Learn your basics and you'll be okay. And if you like the video, click on the like button, the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.